Hey, Algebra 2, we're going to jump ahead. I'm doing this to jump ahead to exponential functions. And hopefully you're sort of familiar with exponentials in the sense that it's exponential means repeated multiplication. So I'm hoping that you have some sort of exposure to that. We've definitely done squared numbers. We've even talked a little bit about cubed and such. So the whole thought process is, like if I'm plugging 1 in for x, well, 2 to the first power is going to give me 2. And maybe on the next one I'm plugging 2 in for that x. And just a reminder that that's repeated multiplication. That's 2 times 2, so that's 4. Same thing with the next one. I'm plugging 3 in for that x. So reminder, hopefully you've seen this before, that means there's 3 2's. 2 times 2 times 2 is 8. And to try to help you out as to why certain rules are what they are is to go one way, we're multiplying by 2. So if I'm asking you to go backwards, then it makes sense that we divide by 2. Divide by 2. So think about what that means for the next number. If I continue to divide by 2, 2 divided by 2 would be 1. If I divide by 2 again, it becomes 1/2. If I divide by 2 again, we're at 1/4 and then also 1/8. And it's certainly worthwhile, if you haven't learned it yet, to understand that 2 to the negative third power, I'm talking about this one now, that's the same thing as 1 over 2 to the third power. But the whole theme on this, I'm going to change colors one more time, is these are a bunch of ordered pairs. So when x is 0, we get a y value of 1. When x is 1, we get a y value of 2. I'll jump down to when x is 3, we get a y value of 8. So what does my graph end up looking like? 4, 5, 6, 7, 8. And then on the flip side, it's not going to give me a negative answer over here. It's just going to approach 0. So I think I have my graphing calculator already set up. And because I could just go to a calculator. Sorry if you're still copying things down. Maybe I can put it right there. If I just type it in as 2 to the x power, and I look at my graph, it looks something like that. Notice it does not cross the x-axis. I could even pull up a table and show you I'm getting positive numbers. And eventually we switch over to scientific notation, and eventually the calculator will probably say that that answer is just 0. I guess not. It's it's scientific notation. 2.8 times 10 to the negative 14th power is very close to 0. So it does not cross the x-axis. Another thing I want to mention is this base. That's what we call the number that's taken to a power, is 2. And when that base is greater than 1, like this one is, we call it exponential growth. Why growth? Because it's growing in size. Maybe a better word to say this is it's increasing to the right. Because if I look at the next problem, and again, feel free to pause the video and write down anything that you want, any questions you want. Notice on the next exercise, the base is 1/2, which is a number that is smaller than 1, and I'm going to call this exponential decay. And the reason why we call it decay is it's decreasing. Maybe you have some familiarity with what it means to decay, like tooth decay, it's getting smaller over time. Trying to think of an example that's not so morbid. But if you look at some of the problems, 1/2 to the first power is still 1/2. 1/2 squared, well, you square each piece. Maybe I'll do this one. So it's 1 squared over 2 squared, which gives me 1/4. 1/2 to the third power is 1/8. And I could go through the same arithmetic and show you that this would be 1 then. And then the same thing with the next one. I hope you have some familiarity with taking something to the negative first power, 1 to the negative first over 2 to the negative first, that anytime you have negative exponents, you flip them. So that's why this answer is 2. This answer is 4. This answer is 8. And that might confirm too that we are decreasing to the right. But again, it's not going to cross the x-axis. 5, 6, 7, 8. It's going to just decrease. And what I like so much about our graphing calculators, as I pull mine up, is it's got that fraction key, y equals. I can just say alpha x 1/2. I just need to go over and delete that 2 now. I think this will work. There you go. You can see that's decreasing to the right now. So again, pause the video, write down what you can, write down any questions you have. Be ready to come to class and ask. Now, the next question is asking for the domain and range. Just a reminder that the domain are the x values. And you probably noticed, I hope you noticed, that x could have been anything, positives, negatives, or 0. And so in interval notation, I like to write it as this, -infinity to infinity. That's the domain. Maybe off to the side, I'll write down all reals. Whereas the range, the y values, I really tried to emphasize that we never crossed the x-axis. Now there's ways that we could cross the x-axis if we shift up and down, but on the first 2 exercises, it didn't even hit 0. It went from 0 and infinitely up. In other words, maybe a different way of writing it, is the y's were always greater than 0. They always got positive answers. And so as we're trying to make the connection on exercise 4, basically it's saying the exponential function that increases as x increases. Well, that's going to be what I call exponential growth. And what that means is the base that I'm talking about must be greater than 1. So as you're looking at your options, is 2/3 bigger than 1? No. Is 1/2 bigger than 1? No. Is 7/8 bigger than 1? No. But 5/4 is. 5/4 is greater than 1. And if you're confused what I mean by that, well, 1 is equal to 4/4. All right, 4 divided by 4 equals 1, and 5 is bigger than 4. The rest of them would be smaller than 1, so that's why option 2 is correct. Now in the next exercise, if you have access to a graphing calculator, I encourage that to help you understand. But there is sort of a rule that we could establish, and maybe I'll just take a step back and talk about the Y-intercept. Is the rule that we have been talking about for a while is when x equals 0. So as we're looking at this problem, if I ask you for the y-intercept, you're going to plug in 0 for x. And think about how we do the order of operations, that you do 3 to the 0 power first, which hopefully you remember something to the 0 power is equal to 1. So the y-intercept on this problem is going to be 7. Now if you wanted to, you could put tick marks in here, 1, 2, 3, 4, 5, 6, 7. Otherwise, I'm fine if you just wanted to put in a dot in there and then say 0, 7, or the y-intercept equals 7. But I'd like to see that on the graph. The next one is really, is it exponential growth or decay? So if we're looking at this, remember all we need to look for is the base in the problem. Well, the base in this problem is 3. That's the number that's taken to the power. And since it's greater than 1, I like to use the phrase exponential growth, which means that it's increasing. So be familiar with both those words, whether I use it or the person here uses it. So what that means is as it goes to the right, it is going up and to the right, but it is still not crossing the x-axis. So I want to see an answer that looks something like that. Not very well drawn. But I could look at the graphing calculator again, and let's just clear that out. And you can even write it the way the problem looks. And if I go to my graph, you get a rough estimate on what it looks like, just like what I drew there. Yeah, I feel like I already did this next one. Just a rough graph and the answer that it looks like. Now the next one's even more complicated. And the reason why it's more complicated is that we have this plus 4 on here. So what is that plus 4? What does adding 4 do to any problem? I hope you remember this from earlier in the year. It shifts the graph up 4 units. So if I ask you for the y-intercept still when x equals 0, I just want you to think about, okay, well, if x equals 0 for the y-intercept, 1/3 to the 0 power plus 4. Now be careful, because something to the 0 power is equal to 1, and when I add 4 to 1, I'm going to get 5. So this y-intercept will be 0, 5. Now, the other thing that's a little bit different is that this base is 1/3, which is less than 1, but this time with it being exponential decay going down and to the right, instead of not crossing the x-axis, it's actually not going to cross the line y equals 4. Why is it not going to cross y equals 4? Because it was shifted up 4 units. So we have exponential decay. But let me introduce another word to you if you haven't seen it before. It is a horizontal asymptote. We call that a horizontal asymptote at y equals 4. Because if I look at the graph of this, again, I'm going to pull up a graphing calculator and let you explore a little bit. Hopefully you take the time to explore that you can make it a fraction, 1/3 to the x power plus 4, and look at the graph. I hope you see that it's not approaching the x-axis anymore, but it's getting closer and closer to the line y equals 4. And it actually looks like it's crossing it or hitting it, but it actually doesn't. Like if you look at the table, well, I'm way up there. It should be, and that's the other thing, is it makes it a fraction, but if I change those to decimals, you'll see that it looks like it's getting closer and closer to 4, even though it's not actually supposed to be hitting 4. And that's what an asymptote is. It's a line that, so the asymptote is y equals 4. It's the line that the curve is approaching. And I think I've talked about everything that I've needed to prepare you for this homework assignment. 10.1 homework should be good to go.